In my 14 years of journey as an IIT JEE Maths faculty, I have seen students facing a lot of problems, especially in questions of summations in Binomial Theorem. So in this video, I am going to simplify your life by giving you 5 different kinds of questions and 5 different types of tricks how to solve those 5 different types of questions based on series in Binomial Theorem. So without any further delay, let us start with it. Let us start with property based questions, that is type 1. In this type 1 questions, you can see a very typical question. You will see that the series will start with 25C10. Then the upper part, n part, is getting reduced by 1 in every term and the bottom part remains 10 in every term. Now how to solve this question? And then once we have solved, I will give you a formula to directly do it. So the step 1 would be to write this series in reverse order. So we have 10C10, then after that 11C10, then 12C10, and this will go till 25C10. Step 2 would be, we know that 10C10 is equal to 1 because every NCN is equal to 1. So we can also write 11C11 is also equal to 1. And hence, since both of them have same value, we can replace 10C10 by 11C11. So if I rewrite my series, it looks something like this: 11C11. So this term 10C10 has now been replaced. Then we have 11C10. Then we have 12C10. And it will go till 25C10. Now in step 3, we can notice a very important thing. And that is this first two terms are forming a formula. And this formula is NCR plus NCR minus 1. This would be equal to n plus 1 CR. Now, this is the formula that is getting formed. So you can see that if you have 11C11 plus 11C10, it will become 12C11. So you can see that what happens in the 1 with the lower bottom end, we will add 1 in n part also, 1 in r part also. Very easy to remember. So if I do this, what happens to my series? Let us see that. So if I rewrite my series one more time, you can see that now it has been compressed from the front end. This becomes 12C11 plus 12C10, and then this will keep on going 13C10 up till 25C10. This first two term, again we can apply the same formula, and now will become 13C11. And there is a 13C10 waiting for it. You can see that the series is getting compressed from the front end. And again you can apply the same formula, what we applied earlier. So what will happen if I keep on doing this? All of these terms will crunch and ultimately you will get a last term, 25C11 from the front end. And there is already a 25C10. So if I apply my formula one more time, it becomes 20C611. That is my answer. You can clearly see that this NCR plus NCR minus 1 is generating a kind of a regression in the first two terms, and because of this the series starts getting compressed and ultimately you get an answer. Now you can always keep on doing this. This is the 3-step process that you can apply in every such question, but it would be easier if I remember this small result. What is the result? If I have MCN plus M minus 1 CN and it goes till NCN, assuming that M is greater than N, of course, then the answer to this would be, if you take the first term, it will have 1 added, so that would become M plus N, M plus 1, C, N plus 1. So what you need to do is simply in this formula, here in the n part add 1, here in the bottom part in place of n also add 1. Directly write the answer. So in this case, you can see that if I directly want to write the answer, what I am going to do? In 25, I will add 1, will become 26. In 10, I will add 1, it will become 11, and that is my answer. So if you remember this small trick, all such questions you can solve very fast. Now, this question can also be solved using one more method, that is summation of series method, and for complicated question, this method will become more useful. So what we can do in this case is write the sum of the series. And this is another way of doing the same thing. तो sum of series method. So what I can do in this question is, I can see that this is a geometric progression where the value of a, that is the first term, is 1 plus x raised to the power 6. The value of r is again 1 plus x. And how many terms are there? So in order to find total number of terms, you can apply this formula 15 minus 6 plus 1. So these many total terms would be there. So answer comes out to be 10 terms. So apply my sum of series, my series will become a, that is 1 plus x raised to the power 6, r raised to the power n, so 1 plus x raised to the power 10 minus 1 by 1 plus x minus 1. If simplified, this will become 1 plus x raised to the power 16 minus 1 plus x raised to the power 6 by x. What they are asking is coefficient of x raised to the power 6 in this. So if I want, this is my step 1. In my step 2, if I want coefficient of x raised to the power 6 from this whole term, from 1 plus x raised to the power 16 minus 1 plus x raised to the power 6 by x, the numerator part should contribute one more power of x. So this would be equivalent to getting coefficient of x raised to the power 7 from the numerator, that is 1 plus x raised to the power 16 minus 1 plus x raised to the power 6. Now if I want to get that answer from this term, the second term, there would be no contribution because the highest power can be up till 6 only. So whatever answer we are going to get is from the first term only, and that will become NCR or 16C7. Now most of such questions, they will not directly give you the answer. They will always give you the answer in terms of NC n minus r. So answer will become 16C 16 minus 7. That would be 16C9. So though this is the answer, but this is what would be given in the option, that is option A. This is another way of doing the same question. Now if you can also do the same question using earlier method, let us see how. Because see, now if you want to apply the old method or method number 2, that will become a shortcut in this case. How? Because if you are looking into coefficient of x raised to the power 6 in this, the first term will contribute 6c6, the next term will contribute 7c6, and it will go till 15c6. This is same as the concept or the question that we saw earlier. Answer becomes, take the highest term, and that is going till 66. Then observe, this is very important. Sometimes few terms might be missing from the beginning, and that we need to keep into account. Or add 1 to the n part and 1 to the n part. So this will become 16C7. So we have added 1 in the n part, added 1 in the r part, which eventually can be written as 16C9. So you can see that our method 2 or the formula that we learned earlier is very fine, very simple, and can give us answer very quickly. Where in the second method is very typical of a series based method and will take some time into doing it. The methods that are usually more complicated would help you solve more complex problems. So when you see that when AGP based questions will come, this method will become more simpler. Now you can see that we have similar kind of question which you can do instantly. I don't think there should be a problem in doing this question. Now in this question, so now this question is given to us. What is happening is NCR plus 2 times n plus 1 CR plus 3 times n plus 2 CR. Like this it is happening. So now there are, in this question, we'll have to go back to the series part. So what we can say is the answer to this question can be written as a series in which we are writing 1 plus x raised to the power n plus 2 into 1 plus x. So you can see that I am rewriting the question in the reverse order now. 1 plus x raised to the power n plus 1. 3 times 1 plus x raised to the power n plus 2. And this I am writing till n times 1 plus x raised to the power 2n plus 1. Out of this, what I want is coefficient of x raised to the power 3. So if I write this coefficient for every term, from the first term I will get nc3, from the second one n plus 1c3, and like this. And since there is also a 2 present here, that 2 will also get multiplied and this 2 will also come here. Like this, from every term we'll get the series that we want. So you can see that now I am doing the same question in reverse order. If you look into this series, now the steps are very simple. Let me write the steps first. The first step would be write the series. In the second step, we are going to find sum of series. Once you have figured out sum of series, we will get the required coefficient, which in this case is 3. Coefficient of x raised to the power 3. In these 3 steps, we are going to solve this question very clearly. So first step I have already done. In the next step or step 2, now I am going to write sum of this series. So you can see that this is AGP. Let us write it down nicely. So 1 plus x raised to the power n plus 2 times 1 plus n into 1 plus x raised to the power 2n. Now multiply this series with a common ratio, that is 1 plus x. Now slide it a little bit, 1 plus x raised to the power n plus 1. This will become n minus 1, 1 plus x raised to the power 2n plus 1. And then there would be a last term, n into 1 plus x raised to the power 2n plus 2. Once you have written it in this manner, we can subtract it and get the answer. So if I subtract this, this will become minus x. 1 plus x raised to the power n. This will become 1 plus x raised to the power n plus 1. And this becomes 1 plus x raised to the power 2n plus 1 minus n into 1 plus x raised to the power 2n plus 2. There are total, if I include the first term as well, 1 plus x raised to the power n plus 1 till 1 plus x raised to the power 2n plus 1. These many terms that are in GP. How many terms are these? Very simple to find. Take 2n plus 1, that is the power of the last term, subtract that from the first one and then add 1. So I am applying a AP concept and the number of terms in AP to get this answer. So this will get cancelled out. Total terms would become n plus 2. So you have n plus 2 terms in GP. We can very easily find the sum of this n plus 2 terms and get the answer. So if I write the answer, let us see what does it become. So A into R, that is 1 plus x. We forgot this term. Raised to the power total n plus 2 minus 1 by 1 plus x minus 1 minus n into 1 plus x raised to the power 2n plus 2. See, once I have done this, we have minus x on the other side. Let us also write that. And if I simplify it now, this becomes 1 plus x raised to the power 2n plus 2 minus 1 plus x raised to the power n. There would be a minus, there would be a plus x term here, plus x term here. Let us just write x. And then we have minus n into 1 plus x raised to the power 2n plus 2 term also. Okay. Now if I just want to write the value of x, the minus will come here, this will become x square. This becomes plus, this becomes x square. This becomes plus, this will again become x. So now what we want out of this sum, this is my step number 3, that is coefficient of x cube from this. If I can get that, I will get my answer. So if I write that down, you can see that from the first one, the first term, that is 1 plus x raised to the power 2n plus 2 by x square. If I want coefficient of x cube from the whole part, I will want coefficient of x raised to the power 5 from the numerator. And that answer will become 2n plus 2 C5. This is the first one. And there is a minus sign also. So let us also take that into account. So this is the answer that we get. From the next term, that is 1 plus x raised to the power n by x square. What we want is coefficient of x cube. So from the whole part and the numerator part, I will again want coefficient of x raised to the power 5. That would be nc5. and then ultimately the last term, that is n into 1 plus x raised to the power 2n plus 2 by x. So from whole I want x cube. The numerator part I will want x raised to the power 4. Hence the answer will become n into 2n plus 2 c4. So my final answer would be sum of these three terms. So answer becomes minus of 2n plus 2 c5 plus nc5 plus n into 2n plus 2 c4. This is my final answer. In this kind of questions, we have three steps into place. What are the three steps? Let us go back to them again. We write the series, then we find sum of the series, then we get the required coefficient. If we do these three steps, we will be able to get an answer. Now, this next two questions we are not going to solve, but I will give you hints how to approach this question. So, in this question, you can clearly see that what is happening is NCR and NCR minus 1 formula is directly getting formed. So, what you have been given is NC naught plus NC1. So, you can see that this is NCR So, this is NCR minus 1 and this is NCR. So, in this term the answer will become n plus 1 CR. So, in this case the answer will become n plus 1 C1. So, you can see that every term will start compressing in the similar manner. So, I have given you a hint. Now, you can easily do it. First term will become n plus 1 C1. The next term will become n plus 1 C2. Then n plus 1 C3. Similarly, the last term will become n plus 1 Cn. Now, here when it is given C0, C1, C2, C3, Cn, it fundamentally means there is an n in the superscript. So, what we can do is we can apply the formula. So, this is the first thing that we did. In the second step, one more thing that you need to understand, there is one more formula. NCR can be written as n by r n minus 1 CR minus 1. This is a very important idea. We are going to use this property to solve a lot of questions. So, if you have this into place, what we can do is, if we have n plus 1 C1, it can be written as n plus 1 by 1. You reduce 1 in the superscript, 1 in the subscript. Similarly, if I have n plus 1 C2, can be written as n plus 1 by 2 NC1. If I keep doing this for all the terms, what is the final series that I am going to get, that I am going to write in the third step? So, I will have n plus 1 by 1 NC naught, then n plus 1 by 2 NC1, and till last term, this will become n plus 1 by n NCN. So, once we have this, so this was correct. So, we had, once you have this, you can write it like this. You can see that we have n plus 1 raised to the power n, and 1, 2, 3 till n will become n factorial, and then we have NC naught into NC1 till NCN. In this next question, again we have to apply the second property that we talked about. So, what we are going to do is, we are going to write general term. In general term, what you can see is there is R, then there is NCR, then NCR minus 1. So, you can see that this is my general term. Why is this important? Because in step 2, I am going to apply a property. What is the property? We know that NCR by NCR minus 1 is equal to n minus r plus 1 by r. This is again a very important property and will be used to solve a lot of questions, especially the calculations becomes very complex. Now, once you have applied this property, this will become r into n minus r plus 1 divided by r. This cancels out. And in the third term, we are going to apply summation over it. You can see that summation, the value of r starts with 1 and it goes till n for n plus 1 minus r. If I open the summation, you can see that it will get split into two parts. Now, here n is a constant and in the second part, r is a variable. So, if I take n plus 1 outside, this is summation of r is equal to 1 to n of 1 minus summation of r is equal to 1 to n r. See, now you should know this very basic result that if I add 1 n times, like 1 plus 1 plus 1, so we are adding 1 n times, the answer will become 1. So this is what happens in the first part. In the second part, what we are doing is 1 plus 2 plus 3, we are adding till n. If I do so, answer becomes n into n plus 1 divided by 2. So this is what happens in the second part. We can substitute both of these values and get our final answer. So this becomes n plus 1 into n minus n into n plus 1 divided by 2, which if subtracted will become n into n plus 1 divided by 2. 60 days to JEE Mains. Let me tell you something that nobody else will. The brutal truth. Right now, you have doubts from class 11th you never cleared. Topics you are avoiding, formulas that you kind of remember. And you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PracBee, we have produced 10 times better result than national average and helped more than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt. They had a strategy into place. And that's what Last Lab Booster program does. Senior ITN faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.